The topic today is equilibrium of a particle, which includes condition for equilibrium of a particle, free body diagram, and coplanar force system. There are many examples that can be studied in this area. For example, here we are calculating the tension in a cable that is carrying a load W with a weight of W, or in this case, another example of carrying load by a crane, and also we are trying to calculate in this case the tension T sub B, T sub C, and T sub D in the cables from the figure you see. And here another example of towing a boat, and then a total load of 50 kilonewton is applied at point A, and we are interested in calculating the forces developed in the cables in this application. Okay, so this is an example of a 2D problem. There's a weight of 40 kilogram held by 3 cables, and we are interested to obtain the tensions developed in the cable in this static equilibrium. So first we need, of course, to draw the free body diagram. And if we consider point A in this case, which is a point that is connecting all these cables together, then take that particle out and draw the free body diagram, which means that you assume that A is a particle, and you show all the forces applied to that particle A. That includes the force in this tension, or the tension in this cable, or the force sub F sub B towards B, and the force towards D, F sub D, or the tension developed in this cable, and also the vertical cable, which is also force sub C. And that helps us to then drawing this FBD or free body diagram helps us to obtain the unknown forces. So in this case, in this particular case, we know the force in this cable C, AC, and then from that we can calculate the forces in the other 2 cables. So in this equilibrium, since A is in equilibrium, the net force at A is 0. Okay, so therefore, if you add the force vectors FB, C, and D, all equal to, some of them equal to 0, and with notation sum, you can show the same thing, F sub B plus F sub C plus S sub D equal to 0, and we can show the same thing with this sum notation or sigma notation. In general, the particle is, for a particle in equilibrium, you know that the sum of the forces applied to that particle is equal to 0. That includes sum of all the forces in x direction with the unit vector I in x direction, plus sum of all the forces in y direction with unit vector j in y direction or in j direction, all equal to 0. That 0 means that is 0 in I direction plus 0 in j direction. So therefore, that one single equation is therefore 2 equations in a scalar form, which is sum of the forces in x direction equal to 0, and sum of the forces in y direction equal to 0. And these are the 2 scalar equations of equilibrium that they can be used to solve for 2 unknowns, to have 2 equations so we can solve for 2 unknowns in a static problem. In this particular case, if we analyze, again, particle A, which is the contact point of all these 3 cables, then you can write the force in x direction is force, and the component in x direction is FB cosine, as you see in this figure, cosine 30, minus FD, minus because FD is pointing towards negative x direction. And then in y direction, we have FB sine, the component of FB in y direction, minus force FC, which is pointing down. So that's why is negative in this case because our assumption is when upward, this direction is positive. And then you have two equations, two unknowns, FB and FD. We can calculate force FB and FD. Force in a spring can be calculated by spring constant multiplied by the deformation of a spring, or F equal to K for spring constant or stiffness of the spring times S for deformation of the spring. For a frictionless pulley and cable, cable can support only a tension. In this condition, there's a pulling force, and the force always acts in the direction of the cable. And also the forces in this cable, along the cable everywhere in this condition will be the same. So T1 equal to T2 on any part of the cable. And the cable is in tension. In this particular example, we have a smooth surface, so therefore we are not considering friction in this problem. And if we want to show the free body diagram as an example of this case, we have a tension T in the cable that is holding the disc here, or the cylinder in this problem. We can show in a free body diagram the normal force from the surface to the cylinder and the weight. So we have the total number of 1, 2, 3 forces, one due to the cable and due to the normal force from the surface and the weight of the cylinder. So then we can write the equation of equilibrium for this particle once we have the free body diagram. Okay, this is an example of solving a static problem. In this case, we have a box with a weight of 550 pounds, and the geometry is shown. And the question is finding the forces in the ropes A, B, and AC. So we always start with drawing the free body diagram. It's very important. Free body diagram can help us to write the equations of motion. And then we can find the forces after free body diagram and writing the equations of motions, equations of equilibrium. So in this case, if we look at again the contact point of cables, which is connecting B, A, C, A, and A, D in this case, then you can show the forces in the cables at FC towards C, FB towards B, and FD towards D for the weight. And again, writing the equations in the scalar form in X direction, choosing X positive to be to the right. In this case, we have FB, because pointing to the negative direction is a negative sign here. Cosine is the component of FB in X direction, cosine 30, plus FC, which is an unknown force, in this case, also another unknown force, 4/5, which is the component in X direction. So we have two unknowns so far, one equation. The next equation is the equilibrium in Y direction, and that also includes a force P sine 30. Sine gives you the component in Y direction. FC 3/5 also gives you the component of force FC in Y direction. You have one more, which is the weight in downwards, and downwards is going to be negative because our assumption is that upward is positive. So writing all this gives you our second equation, and we have two equations, two unknowns. We can solve this and we obtain the forces FB and FC. Thank you.